this question. There are 15 students in a class. Everyone has to be ranked from 1 to 15. In how many ways can they be ranked such that rank of one student is always greater than the rank of other student? Second question is, this should be the order of 5 of the students. Okay, try this. Now we're just trying to use the same concept, but trying to build more advanced questions on it. There. So you can assume the students to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, and O. These are like 15 students. Okay. In how many ways can you rank them from 1 to 15 such that the rank of A is always greater than B? Okay. So maybe even before jumping there, let me ask you one simple question. You have 15 students who need to be ranked from 1 to 15. In how many ways can you do it? No conditions. Simple questions. In how many ways can you rank 15 students?
15 factorial.
15 factorial, is it clear?
Yeah.
You have 15 students. Rank of student 1 could be, has 15 possibilities, then 14, then 13, then 12. Or you have 15 students, arrange them in a line, just shuffle them, 15 factorial. And whosoever is on the first is rank number 1. So if there are no constraints, it would be 15 factorial. Now these are 2 constraints that I'm giving you. Now how do you solve it? Question number 1, the rank of A is always greater than rank of B. And that's where the beauty of this topic comes into the picture, that you probably can't solve it manually. You can't keep on counting the case because there are so many cases. See, because it's a rank, right? Right? So ranks can't be same is the assumption here by default. Otherwise, what you would have to do is, very well said, you'll have to then divide that, okay, case number 1, A greater than B. Case number 2, rank of A is equals to rank of B. So in how many ways can it be done? 15 ways, right? Because both of them can get what? 15 rank, 14 rank, 13 rank, 12 rank, till 1 rank. Then you would have to count both of these cases individually. We would have questions on this concept as well.
Okay.
But abhi ke liye, because students are to be ranked from 1 to 15, it's a very fair assumption that no 2 students can have the same rank. Then here, I think like question number 1 was fairly simple. So see, you can't definitely do it manually. Hence, what do you do is, I have a total number of possibilities as 15 factorial. 15 factorial is the total number of possibilities. Now in this, I know, see, rank of A will be either greater than B or rank of A will be less than B. These are the only 2 possibilities to arrange A and B, right? A will be either before B or A will be after B, right? So because these are 2 people, A and B, they can be arranged in what? 2 factorial ways. And hence, by symmetry, we can say, because there is no additional constraint, in half of the cases, A will be greater than B, in half of the cases, A will be less than B. So the answer to the first question becomes 15 factorial by 2 factorial. 15 factorial by 2 factorial. Okay. So see, there are 15 positions, right? Now what you're saying is A ka rank is always greater than B. Then you'll have to individually count. Here, when A is here, sorry, A ka rank is greater than B. Let's assume ranks are in like absolute numbers. So if A ka rank is 15, B can get any of the rank. Then when A ka rank is 14, B ki sari possibilities. Then A ka rank is 13, all the possibilities. Then 12 till 1. And then you have to count them, add them, and then solve that expression to bring it in this fashion. Because if the option is 15 factorial by 2 factorial, you will have to solve individual expressions to bring it in this form. You can do it, but it would be too long. Was this method clear? 15 factorial by 2, that by symmetry we can divide it. If it's clear, I want all of you to solve this. Expression number B. How many ways can you rank 15 students such that the order of ranks are like this? A, C, D, B, E. You know, you have a total of 15 factorial ways, right? Now in 15 factorial ways, if I just take all the possible combinations for the rank of A, C, D, B, and E, these are 5 students, right? Because these are 5 students, in total, how many possibilities are there to rank them? I have 5 factorial possibilities, which is 120. So I can rank these 5 students in 120 possibilities, but I want only one single possibilities out of this 120, right? Which means in my total 15 factorial ways, these 5 students can be arranged in 120 possibilities, but I want only one. So I will just divide this particular answer total by 5 factorial. Why divided by 5 factorial? Because I want only one of the possibilities out of 5 factorial. So probability of having this is nothing but 1 upon 5 factorial. Does that answer? And why 5 factorial? Because it could be A greater than D, greater than C, greater than B, greater than E. It could be A, then E, A, then C, etc. etc. So in total, there would be 120 cases for this. But I just need to take one of the cases. So if 120 cases in total corresponds to 15 factorial, what would one case contribute to? Simple unitary method, 15 factorial by 5 factorial. Yeah, because I want only one case, right? I want A greater than C, greater than D, greater than B, greater than E. Now these 5 ideally can be arranged in 120 ways, but I just want one way. See, let's consider this like very simply. Always when you're confused, take 3 examples. In how many ways can you arrange A, B, and C such that A is always greater than B is always greater than C? In total, I have 3 factorial ways to arrange it, right?
Yeah.
To arrange these 3 numbers. But I want only one of the case for this to happen. So this is nothing but 3 factorial by 3 factorial, which is nothing but 1. Or maybe in the interest, let's say you have 4 numbers, right? You have 4 people, A, B, C, D. In how many ways can you rank these 4 such that rank of A is always greater than B is always greater than C? Now, ideally, let's say rank is 1, 2, 3, 4, right? So I can have A ka rank greater, right? So A, B, C here and D here. Either this becomes my one case, or rank of A is this, rank of B is this, rank of C is this. This is my second case. Similarly, A this, B this, C this. Is there anything else I'm missing? Yeah. A this, B this, and C this. Right? These are the 4 total number of cases in which rank of A is always greater than B, greater than C. And by greater, I'm assuming 4 is greater than 3. So total, I have 4 cases. How do we get 4 cases? In total, I can arrange these 4 students in 4 factorial ways. But
Yes, got it.
these
Got
4
it, got it.
factorial cases will have 3 factorial combinations for this. Because I want only one of the cases, I will divide this by 3 factorial and the answer comes out to be 4. Everyone, was this concept clear? I don't want you to remember or learn this. Otherwise, it would become very difficult in CAT. I want you to understand that why are we dividing it by 3 factorial or 4 factorial? And when confused, do simple examples. Take a 2-digit number, take a 3-letter word, make patterns for yourself, and then understand this formula. Fair. Ayushi, Gaurav, Shubham, everyone clear? Dhruv?
So I got this method, but what I tried was कि मतलब मैंने ना I tried to arrange this A C D B E in the sequence, like we can arrange it in 10 times for the 15 places. If we'll consider it as a
No. See, what you're doing is you are considering them in consecutive terms. So you're always saying कि A is immediately greater than C. Then there would be 10 or 11 cases. But
okay, got
it is
it.
not given that they have to be immediately greater than it.
Correct. Okay, sir.
Okay, fair. Thanks. Chalo, let's move on to the next question then. Let's solve this one. Before we jump onto this, there is one more method to solve B. I was just thinking about it right now. See, you have to rank 15 students, right? You have constraint only in 5 students, right? So what do? You first of all select the 5 students. Just a minute. 5 by 10 factor. And then you multiply the remaining with the time. Okay, cool. I don't want to spoil that over. I will discuss this method in this question. The same method is also applicable here. So you try this and then we'll discuss both the methods. So how many 4-digit numbers can be formed with repetition not allowed using the digits 1 to 9? So it's a 4-digit number, 1, 2, 3, 4-digit number. And how many such numbers can you form? And repetition is not allowed, digits 1 to 9, such that 1000 term is greater than 100, then 10 and 10 unit, right? So if it's A, B, C, D, A has to be greater than B, greater than C, greater than D. How many such numbers are there? Same method should not take more than 30 seconds now. Good, Raman. Very good here. Raman is the only person who is understanding the methods. Good. The answer is correct. Others? Simple question, right? Based on what we just learned. These are simple arrangement questions, very important for CAT. Let me ask Muskan. Muskan, can you explain? How did you solve it?
Yes, sir. So, sir, like in previous question, what we did is for 4-digit number, we have 1 to 9, and for that we have total as like 9 into 7 into 6 will be the total possibilities where we'll have 1000 digit greater like the case the 1000 term is greater than 100 to 1 and then 10th and then unit 1.
How many total numbers would be there? 9 into?
9 into 8 into 7 into 6.
I hope this is clear to everyone because repetition is not allowed. I have only 1 to 9 numbers. So 9 here, then 8, 7, 6. Fair.
And these are 4 digits. So by unitary method, we can say that the total number of cases will be 4 factorial.
4 factorial, right? Because A, B, C, D can be arranged within themselves in 4 factorial ways. Like it could be whether A is greater or B is greater or C is greater or C greater than A greater than B. So in total, there are 4 possibilities to arrange A, B, C, and D or to rank A, B, C, and D. But I want only one. So I will divide this by 4 factorial. Very good. This is correct.
Sir, I tried that approach only. One doubt only I had in the last question, we had 15 ranks, right? I mean, 15 students with different 15 ranks.
Correct.
So we knew that total there are 15 ranks. So we divided it by 15 divided by whatsoever it came by 5 factorial, right? 15 factorial divided by 5 factorial. So there was arrangement in the numerator also, there was arrangement in the denominator also.
Correct.
Yeah. In this case, in the numerator, we have total numbers. Irrespective of their arrangement, we have total numbers. And in the denominator, we are only considering the arrangement of the case.
Correct. So see, even in the last cases, we had that 15 factorial was the total number of cases, right? Total number of ways in which you can rank 15 student is 15 factorial.
Okay,
Even
so
here,
total divided by the case. That's what we are doing.
don't try to remember this. Just try to understand why are we doing this. It has to be total number of cases, but it includes, say, 4 factorial cases. We just want 1 out of 4 factorial case. So if 4 factorial cases ka sum is this, 1 ka kitna hoga? It is 1 by 1 factorial.
Okay.
Either this, see, alternatively, always try to think 2, 3, 4 methods for PNC that will really sharpen your mind. How many 4 digits number can be formed with repetition not allowed using the digits 1 to 9? Repetition is not allowed. We just want a 4-digit number, right? In total, I have how many digits? I have 9 digits. In how many ways can I just select those 4 digits, which will form my number? I can select 4 digits in 9C4 number of ways. Using 9C4, now I have chosen 4 distinct digits. Now, in how many ways can I arrange those 4 digits? I can arrange these 4 digits only in one number of ways. Why? Because whatever is the largest has to be on my 1000 position, followed by 100, followed by tens, followed by unit. I can't arrange them in 4 factorial ways now. I can only arrange them in one ways. So again, if you solve this gives you same 9 into 8 into 7 into 6 upon 4 factorial. This is method 2, where we are trying to select first and then trying to arrange them. Clear? Ye wala method bhi? So Raman, in this, what I'm doing is I'm just selecting the 4 digits that I need to form a 4-digit number. I can select 4 digits in 9C4 number of ways. I have 9 digits. So 4 digits can be selected in 4 number of ways. Now, once I've selected the 4 digits, say digits are 1, 3, 5, and 2. I've selected this, right? In how many ways can I arrange them? I can only arrange them in one number of ways, which is 5, 3, 2, 1, right? Right? Because 1000 term has to be greater than 100, then greater than 10, greater than 100 digit. So 94 into 1. Clear?
Okay, sir. Understood.
Chalo.
Yes.
Then let's try to apply the same method here. There are 4 houses in a row. 1, 2, 3, 4. House number 1, 2, 3, and 4. This guy has to paint the houses with either of these colors. He can either paint it with V, I, P, G, Y, O, R. So there are 7 possibilities of painting a particular house. In how many ways can I do it? For these 3 cases. Chalo, let's look at this. All 4 houses are painted with different colors. Again, we have both the methods. If I have to solve it directly, all the 4 houses have to be painted different colors. So out of 7 colors, I will choose 4 colors in 4 number of ways. Once I have 4 colors, I can arrange them in 4 factorial number of ways. Why arrange? Because I can paint house number 1 with either of this 4 color. Whatever I've chosen for house number 1, second one ke liye I'll choose something else, third wala something else, fourth something else. So I'll just arrange them in 4 factorial number of ways. So the answer to first is 7C4 into 4 factorial. Answer to second should be 2 of the houses are painted with V and I. So let's say V and I मैंने already choose कर लिया, ठीक है? Now, so 2 of the houses are painted with V and I, and बाकी 2 के लिए again I can choose any of the 2 colors. इसमें one thing that is missing in this question is all the houses have to be painted with different colors only. They have to be painted with different colors only. It's just कि 2 of the houses are painted with V and I. So V and I मैंने already choose कर ली है. बचे हुए 5 out of 5 I can choose 2 colors in 5C2 ways. Why 2? Because I already have 2 colors. One is V, one is I. The only pending colors are 2. So I can choose them in 5C2 number of ways. Now I have all the 4 colors, including V, I, and the 2 that I've just chosen. Now I can arrange them in 4 factorial number of ways to paint any house with any color. So this should be the answer to the second question. The answer to the third question should be no 2 adjacent houses are painted with the same color, right? So for example, for house number 1, I have how many possibilities? 7 possibilities. Whatever color I have chosen for house number 1, I can't choose the same color for house number 2. So for house number 2, I have how many possibilities? 6 possibilities, because I can choose the one that I have already painted house number 1 with. Now for house number 3, how many possibilities do I have? I have again 6 possibilities, right? Because out of 7 colors, I can't use the color that I've used in house number 2. Apart from that, I can use the color I've chosen for house number 1, but I can choose the one that I've used for house number 2. So 7 minus 1, 6. Similarly, for 4, I have 6 possibilities. So the answer to question number 3 should be 7 into 6 into 6 into 6. So yeah, I think we have covered the first module of PNC, which is simple permutation, combination, all the variance, selection, arrangement. And these type of questions are very common in CAT. This was LOD1, where you just have to select, arrange it, right? And then there are different ways to solve it. How do we fasten our calculation? So all of that we have done here, right? Now, second concept again is how do you calculate rank of a word? It's just a fancy concept, but in terms of how do you do it, it is same, right? How do you rank a particular word? So we'll learn this using a simple example. So for example, rank of a word is nothing but how many words are coming before that. So for example, there's a word ABC, right? Let's consider ABC, right? So how many total words can you form using the words ABC? ABC, such that repetition is not allowed. ACB, BAC, BCA, CAB, and CBA. I can form 6 words using the letters ABC. If I have to arrange them in a dictionary, I would always arrange them alphabetically. So pehle ABC aega, then ACB, then BAC, BCA, CAB, CBA. Now, if the question says find the rank of the word BCA, How do you calculate the rank of the word BCA? इसका rank कितना होगा? First, second, third, fourth. So the rank is fourth, which means you will try to calculate how many numbers are there or how many digits or how many words are there before this, and then you will add 1 to that. Okay? Concept is clear, then we'll solve some questions to master this concept. Let's solve this question. The right answer is 85. Let's see, guys, others who are making mistake should not have happened because it's simple question. Find the rank of the word POINT, right? So alphabetically, P comes what? When? So if I have to arrange these words alphabetically, first will be I, right? All the words starting with I. All the 5-letter words starting with I, right? Then what would be next after I? It will be all the words choosing N. Then
O.
And then P, right?
P.
Bad. We don't have to go farther than P. So even in P, what would be the second letter after P? It would be I. So all the words with PI. Then all the words with PN. And then PO. Now even in PO, I will start with I. Right? Okay. We are already I, so we don't have to move forward. After I, will start with N here. And then it has to be T. Right? So this would be my rank, which means these are the number of cases I have to add and count. So how many ways are possible here?
4 factorial.
4 factorial. I have 4 letters here, 3 here, 2 here, 1 here. Repetition not allowed. These are the only number of letters. So 4 factorial, same 4 factorial here, same 4 factorial here. So 4 factorial into 3, 24 into 3 is 72. What about this? How many ways are possible?
6 ways.
Which is 3 factorial. So 6 ways here, 6 ways here. So 12, 72 plus 12 is 84. So the rank of this is 84 plus 1, 85. Chalo, cool. So concept 2 was this. How do we calculate rank? And then there could be a lot of combinations of this. In interest of time, maybe you'll get homework on those questions, but concept is this one. Third concept is number of diagonals. So can anyone tell me what is a convex polygon? Any student who knows what is a convex polygon? So convex polygon is a polygon where the interior angles are always less than 180 degree is what a convex polygon is. So for example, triangle. Triangle mein you can't have any angle greater than 180 degree. Square, rectangle, pentagon, all of these angles are always less than 180 degree, right? This is less than 180, less than 180, less than 180. So if the interior angles of a convex polygon are always less than 180 degree. Okay. Now tell me this thing, just a minute. Yeah. So if I have to ask you, okay, calculate the total number of diagonals in say a triangle, what would that be?
0.
Triangle don't have any triangle. 0.
0. There are no diagonals here. Okay. Now let me ask you the same question here. Calculate the total number of diagonals in a square or a rectangle.
2.
Everyone, this is the first diagonal. This is the second diagonal. Right? So diagonal is nothing but a line, right? How many points do you need to draw a line?
2.
2.
2 points you need. Okay. Fair. So answer here was 2. You have 2 lines where you had a rectangle or a square. How many diagonals do you have here?
5.
4. 4. 4.
4. 4 or 5?
4.
Everyone,
So it's 5.
try. See, this is diagonal 1,
5.
diagonal 2.
5.
All I'm asking you guys is just to try drawing it. Any color?
Yes,
Blue.
5.
1, 2, 3, 4, and 5. In total, I have 5 diagonals. Right? So
Yes,
is there any pattern that is coming up, that for 3 sides I had 0, for 4 sides I had 2, for 5 sides I have 5? Any pattern that you foresee?
NC2 by 2.
And
NC2 by,
okay, sure.
so n into n minus
NC2
c by
by
2.
minus n.
NC2 minus n. Okay. See, the reason I'm doing this exercise is, how do you derive formula for yourself? Again, you just have to come up with some formula which suits this. NC2 by n was one thing, but it doesn't work here, right? 4C2 is 6. This is 2 here. So it doesn't work. But 6 minus 4 is 2. So yeah, this is working. 3 minus 3 is 0. This is working here. 5C2, 10 minus 5, 5. It is working. So the number of diagonals for an n-sided polygon is what? NC2 minus n. And how do we get this? If I just have to look at this formula, like functionally, I have n points, right? Say point number 1, 2, 3, 4, 5, 6, 7, 8 till n. Right? I have n points. To draw a diagonal, first thing is, out of n points, I can take any 2 points to draw a line. So out of n points, how many total lines can I draw? It is NC2. But here, there would be certain lines which are not diagonals, right? These will be the edges. If I join these 2 lines, this is the edge. This is not a diagonal. Hence, I will have to remove all the edges. So because there are n points, there would be n edges. So I will remove those n edges, and then whatever are the leftover lines, they have to be my diagonal. So the total number of diagonals for an n-sided convex polygon is NC2 minus n. Is this conceptually clear by this formula? Everyone? Same thing that we just discussed. Fair? Then let's jump on to the question. Before jumping onto this, 2 concepts. Can anyone tell me what are collinear points? Your geometry is in progress, so I would expect you guys to know it. What are collinear points?
Points in the same line.
Points in the same line. Okay. So collinear points are nothing but points in same line, which means, say I have 3 points. If these 3 points are in the same line, they are collinear, which means when would they be non-collinear? When they are not in the same line, like this. Like I can't form a single line using these 3 points. Then they are non-collinear. Now please try this particular question. Find the number of straight lines, triangles, and quadrilaterals if there are 15 non-collinear points. These points are not on the same line. How many straight lines can you draw using 15 such points? Fairly simple question. Looks difficult, but it's really simple. See, there are 15 non-collinear points. To draw a line, what do I need? To draw a straight line, I just need 2 points. There are 15 points. In how many ways can I select 2 points? 15C2. That's my answer. To have a triangle, I need 3 non-collinear points. Yeah, so every points are non-collinear. So I just have to select 3 points and I'll be able to draw a triangle. 15C3. To draw a quadrilateral, I just need 4 points. They all 4 should not be, like 3 of these 4 should not be linear. Yahan pe to, because every 4 points are non-collinear. Like this, if I join any 4 points, I will make a quadrilateral. So in how many quadrilaterals can I make? 15C4. Clear? Perfect. If this is clear, let's see who can solve this one. Now you have 11 points, out of which only 5 are collinear, which means 6 points are non-collinear. Now, how do you form the total number of straight lines? Just a concept for everyone. If I have 3 collinear points, I can only draw one straight line from that, right? Because whether it's this or it's this or it's this is essentially one straight line only. These are not 2 different lines. 5 points are collinear. 1, 2, 3, 4, and 5. And here you have some 6 pointers. on 6 points, right? It's a non-collinear. Find the number of straight lines. This is a brilliant question, guys. Make sure you attempt this. This is the most important question. बहुत ही conceptual सवाल है, guys. ये. Let's see. See, question number 1. How many straight lines can I draw? First, now, how many straight lines can I draw using 11 points? If these would have been 11 collinear points, answer would have been simple, which is 11C2. Right? It would have been simple 11C2. But these are not non-collinear points, right? Some of them are a collinear, and hence this 11C2 will have these cases as well, where I'm counting these as 3 different lines, but ideally these are only one line, right? These are not 3 different lines, and hence what I'll do is, these are the total number of lines that are possible. I will subtract all the lines that are possible using the collinear 5 points. I have 5 collinear points. How many lines can I draw using 5 collinear points? I just take any 2 points and I will join them. So in 5C2 ways, I have the possible ways of drawing lines between these 2 collinear points, right? But ideally, these should not be counted, and hence I'm trying to subtract them using from 11C2. Right? But here the only catch for you to remember is, see, I still, if I remove all of it, right? If I remove 5C2, what I've done, I have removed all the permutation combination within these 5. Right? But still, there is at least one line that I have to calculate, right? Using these 5 collinear points, I can at least draw one line. So that is also removed if I've taken minus 5C2. So I will have to at least add +1 so that I can include this one line that I can draw using the 5 collinear points. And hence the answer to the first question, number of straight line, is what? Total 11 points, 11C2 minus, I removed all the permutation combination within the collinear point. So it's minus 5C2, but I then added it back. So +1. So see, method 2 is exactly same that he is discussing. You can take any one point from here. You can take any one point from here, and then you can join them. So it is what? 6C1 into 5C1, and then join them and you'll get a line. Or you take any 2 points from non-collinear points, you'll be able to draw a line, right? So plus 6C2 plus these are 5 collinear points, right? 5 collinear points. So you only get one line from here. So you just do this. Either of these approach, you will get the same answer as 46. Second question, number of possible triangles. Okay. Again, what do I need for a triangle? I just need 3 non-collinear points, right? I just need 3 non-collinear points. So again, same thing. If all the 11 points would have been non-collinear, the answer would have been 11C3. But I know I can't choose all the 3 points from here. So I will have to remove those cases when all the 3 pointers are chosen from here, right? Because I can choose 2 from here, 1 from here. I can choose any 3 pointers from here. It will form a triangle. Or I can even choose 2 pointers from here and 1 pointer from here. Even that will form a triangle, right? So everything works, but I can choose all the 3 pointers from these 5. So I will simply remove those cases. I have 5 collinear points, and how many ways can I choose 3? 11C3 minus 5C3. This becomes my answer to question number B. Clear? Okay. Last question. How many quadrilaterals can you form? Now simply, what is a quadrilateral? It's simple 4 points, right? Out of these 4 points, you join them, you form a quadrilateral. But here the only catch is, see, the 2 pointers, maximum 2 of these pointers can be a collinear, right? If 2 pointers are collinear, you can just join them and then form a quadrilateral. But if there are 3 collinear points, you can't join them and then form a quadrilateral. That cannot happen, right? So for a quadrilateral, what you need is at least 2 collinear, maximum 2 collinear points can work for me. So again, same method. You have 11 pointers. Ideally, you would have made 11C4 cases, but then again, this includes certain cases where you have 3 pointers from a collinear region, right? Like we just discussed that at max, I can only have 2 collinear points, right? So I will subtract those cases where 3 are collinear. I will subtract them, and I will also subtract when all the 4 pointers are a collinear, right? And how many cases can I have 4 collinear points? I have 5 pointers, so this is simply 5C4. In how many ways can I form a quadrilateral? where 3 pointers are collinear. I have 5 pointers. So out of 5, I will simply choose 3, 5C3 into the remaining 4th pointer. I can choose in 6 ways because I have 6 non-collinear ways, right? So it is simply 5C3 into 6C1 is the total number of cases to form a quadrilateral with 3 pointers being collinear. Just do the maths and you'll get your answer.